So let's start by defining and understanding some terms, some important terms in thermodynamics. So from time to time, you're going to come across terms like system, surroundings, and state of the system, state functions, and energy and mass transfer, and so on. So what we mean by system in thermodynamics, it's a part of the universe, that's being studied, that is being studied. And everything else except the system in the universe is called surroundings. So everything around the system, surroundings, everything else in the universe. Everything else in the universe. So together, system and surroundings, systems plus surroundings, make up the universe. So now you might ask, what exactly is the system? And you can define the system however you like. It's completely up to you. So you can define the walls and the boundaries that exist between the system and the surroundings. And you can say, this is the region I specify as the system, and everything around it, everything apart from it in the universe is the surroundings. So let's say you just take a simple example. It could be, you can define as a system as a simple test tube with some chemicals in it. So this is your system, and you define your walls and boundaries, and everything outside is your surroundings. So you get the idea. So now a system in thermodynamics can be of three types. You can have either an open system, a closed system, or an isolated system. So when you say open system, let's say you just consider a simple example of a saucepan with some soup in it that's boiling, and it's kept on a stove. You've defined your system as this saucepan with soup in it, and everything around it is the surroundings, including the stove, the air around it, and everything else apart from the saucepan with soup is the surroundings. But the only thing here is the saucepan is actually open to the surroundings, and the reason it is called an open system is because it allows for free exchange of both energy and mass transfer to occur with the surroundings. So what we mean by that is, as you can see, as the soup is boiling, water is escaping from the saucepan as steam. So you can clearly see that there is some mass transfer, or there's some matter transferring between the system and the surroundings. And then you can also add, let's say you can add some spices to it, some salt and some pepper or some other spices to it. So there is clearly, you can actually put in some mass into the system. So it is allowing for mass coming from the surroundings into the system. So the mass transfer part of it is very clear. The matter transfer between system and surroundings is very clear. It is easy to understand. So coming to the energy transfer, it's a little more tricky to visualize how energy exchange is happening. So you bring the saucepan close to the heat source. Obviously, that is how the soup is boiling. So the energy is being transferred from the stove to the contents in the saucepan, and the way it is doing it is the air around here is really hot, which means the air molecules here are jiggling really fast, or they're constantly bombarding with the atoms in the body of the saucepan, and then these atoms in the saucepan in the solid state are again vibrating really fast because of the kinetic energy that they've acquired from the air around the saucepan. And then they in turn transfer some of their kinetic energy to the soup, the atoms and molecules in the soup, and that's how the soup gets hotter and hotter, and then it starts to boil. So you have effectively, what you've done here is transferred the heat energy from the stove to the contents in the soup. So there is a clear energy transfer, heat energy transfer from the surroundings to the system. So now similarly, when the steam here is escaping from the saucepan into the surroundings, steam is also really hot. So it is actually taking some heat energy from the system to the surroundings. So you can also transfer some energy from the surroundings to the system by doing some mechanical work on the system. Let's say you put in a stirrer or a ladle and you basically stirring this back and forth, stirring the soup back and forth. So you're doing some mechanical work, and as a result you're imparting some energy to the contents of the system, or basically you're able to achieve this energy exchange between the system and the surroundings by virtue of either heat or by virtue of doing some work on the system. So schematically, if you just want to draw an open system, let's say this is your system and it is open. So you're letting energy and matter freely go into the system. So everything around the system is surroundings, and you are also letting energy and matter to go out of the system into the surroundings. Matter and energy. So there is a free exchange of both here. So now coming to the closed system. So now I can make this saucepan a closed system by just putting a lid on top of it, right? It's as simple as that. So you're not letting the steam come out of the saucepan. So here what's happening is there is a free exchange of energy. There's exchange of energy between the system and the surroundings, but there is no exchange of matter, or there's no mass transfer. So it is as simple as that. You're not able to add spices to the soup. You're not letting the steam come out of the saucepan. All you are able to do is transfer the energy by virtue of heat from the stove into the saucepan, and then the saucepan can itself become hot, and then the air around it is becoming hot as well, and so that's how it is transferring some amount of its heat energy to back to the surroundings. So there is an exchange of energy, but there's no exchange of matter. So if you see here a closed system, so you have energy coming in, some energy going out, but there's no exchange of mass or matter. So now coming to the third type of the system, which is an isolated system. So in this, let's say you have the example for a very classic example for an isolated system would be a thermos flask. So let's say you have let's see if I can just draw a quick schematic. So let's say this is a thermos flask. And as you know, thermos flask generally is used to keep the contents inside the flask, whatever you're having. It could be a coffee or it could be something cold, and you want to keep the contents either cold or hot for a long period of time, then you use a thermos flask. And what is happening here is obviously it's not letting any contents go in and out. There's no mass transfer happening. There's no matter transfer between the system and the surroundings. But there's also no energy transfer. At least that's what we hope. There's no energy transfer between the system and the surroundings. Of course, this is not an ideal isolated system, because even in a thermos flask, there will be some amount of energy transfer. That's why your hot coffee is going to become cold after say a day or so, and similarly cold things can come back to room temperature. So this will happen over time. So this is not an ideal isolated system. And in fact, it is really rare to find truly isolated systems in this world, because there is always some amount of leak of energy between the system and the surroundings. So anyway, this example comes sort of close to what we mean by an isolated system. So there is no exchange of matter or energy. So we'll talk about another important term that keeps coming up in thermodynamics, that is the state of the system and the state function, in the next video.